let S and T be to C linear transformations from C squared to C squared and over the field C, right? So which are C linear transformations means the vector spaces are C squared over C to C squared over C, and I be the identity transformation on C square, then which one of the following statements are necessarily true on it? So St minus Ts whole square equal to lambda into I. That means St minus Ts whole square is a scalar matrix, right? The second one, the characteristic polynomial of St minus Ts whole square equal to x minus lambda whole square for some lambda belongs to C. And option C, if St minus Ts has only one eigenvalue, then St minus Ts can be written as lambda I for some lambda belongs to C. That means the matrix St minus Ts, simply the commutator of S and T. St minus Ts is a scalar matrix. If St minus Ts has only one eigenvalue, then St minus Ts whole square is the zero transformation under. So then which one of the following is nalugu options? S and T are C linear transformations from C square over C to C square over C. So what is the matrix of S and T? So matrix of T is equal to 2 by 2 matrix kada. So S the gudanga 2 by 2 matrix. So St minus Ts is equal to some C and some A and St minus Ts. So which is the 2 by 2 matrix, right? 2 by 2 matrix. So if St minus the commutator St minus Ts, the trace of St minus Ts is always equal to 0, right? So the characteristic equation of A, that means St minus Ts is equal to lambda square లేదా x లో రాద్దాం, x square minus trace of A, where A is equal to St minus Ts into x plus det of S, which is equal to 0. So but this value is equal to 0 only. That means x square plus det A equal to 0. So that means x square equal to minus det S. So det A is a constant real complex number. So assume that this value is equal to some lambda. Alright. So x square equal to lambda. So by Cayley's-Hamilton theorem, every characteristic equation satisfies its own matrix, right? So that means A square is equal to lambda I. A square is equal to lambda I, where A is equal to St minus Ts. Whole square is equal to lambda I. So this is true, where lambda is a complex number. Right, sir? So option A is true, sir. So the characteristic polynomial for St minus Ts whole square is x minus lambda whole square అన్నాడు. కానీ ఇక్కడ St minus Ts whole square equal to is a scalar matrix అన్నాడు. So the characteristic polynomial of lambda I is equal to x minus lambda whole square, sir. So therefore, which is equal to St minus Ts whole square. So the characteristic equation of St minus Ts whole square is also equal to x minus lambda whole square. So this one is also true. If St minus Ts has only one eigenvalue, then St minus Ts equal to lambda I అన్నాడు. అంటే A కి ఒకే ఒక ఐగెన్ వాల్యూ ఉంటుంది అంటున్నాడు. A కి ఒకే ఐగెన్ వాల్యూ ఉంటే then St minus Ts whole square is equal to lambda అని రాయొచ్చు. అవునా? మరి రాయొచ్చు అలా? చూద్దాం. సపోజ్ lambda is the only eigenvalue. అంటే రిపీటెడ్ eigenvalue అన్నట్టు 2 by 2 matrix కాబట్టి. That means but St minus Ts is a commutator. So the trace of the commutator is 0, sir. So therefore, the trace of A, where A is equal to St minus Ts, equal to 0. But lambda is the only eigenvalue, so which is the double root. That means lambda plus lambda is the trace, so which is equal to 0, sir. That means 2 lambda is equal to 0. That means lambda is equal to 0 is the eigenvalue. Lambda is equal to 0 is an eigenvalue. So that means St minus Ts. ఏమవుతుంది సార్? రెండు ఐగెన్వాల్యూస్ జీరోస్ అండి. రెండు ఐగెన్వాల్యూస్ జీరోస్ అంటే దట్ మీన్స్ ఇట్ ఈస్ ఎ నిల్ పోటెంట్ మ్యాట్రిక్స్. సో నిల్ పోటెంట్ మ్యాట్రిక్స్ ని లాంబ్డా ఇంటూ ఐగా రాయాలి. సో దట్ మీన్స్ సో ఈ ఫామ్ లో ఉండొచ్చు మేబీ 0 1 0 0. ఇట్ ఈస్ ఎ నిల్ పోటెంట్ మ్యాట్రిక్స్, సో విచ్ ఈస్ నాట్ ఈక్వల్ టు సమ్ లాంబ్డా ఇంటూ ఐ. సో therefore the statements option C is wrong, necessarily true అన్నది. And if St minus Ts has only one eigenvalue, then St minus Ts whole square is the zero transformation and అవుతుందా? ఓన్లీ ఐగెన్ వాల్యూ అయితే దానికి ఐగెన్ వాల్యూస్ ఏమైతే సార్ జీరో ఐగెన్ వాల్యూస్ అవుతాయి. జీరో ఐగెన్ వాల్యూస్ అవుతాయి. సో దట్ మీన్స్ ద మ్యాట్రిక్స్ St minus Ts should be the nilpotent transformation, right? Nilpotent transformation. So it must be the matrix of this one 0 1 0 0 or 0 0 1 0 or any 2 by 2 nilpotent matrix. E form lo ne untundi. So but it should be then 2 by 2 matrix kabatti whole square should be equal to 0. So that means option C is true. So therefore options A, B and D are correct, right? Thank you.